So before the test tomorrow, I wanted to at least give you another opportunity to look at a problem that involves finding the least square regression line for a data set, using that least square regression line as the model for the data to make a prediction for a given value of x, predict what y should be, and then to calculate the residual for a data point that's in the set. So let's go ahead and grab our calculator here. I'm going to turn it on, and I believe I've already entered this data. So if I hit stats and go to edit, you can see in my data set I've got the 5, 6, 2, and 2 entered for x, and over for y I've got the 9, 14, 5, and 7. If I needed to clear out old data, what I would do is go up to the header there, the column header where it says list 1, and I would press clear and enter, and that would clear the data out, and then I could enter my data. So I could enter the 5, the 6, and the 2, and the 2. Now as soon as I have the data in, I could take a look at it as a scatter plot. If I was to press second and then stat plot, I would turn plot number 1 on. I can see that it is a scatter plot, and I'm reading my data from list 1, list 2. And at that point, when it's set up, I would probably just press zoom and 9 so I could see those 4 points. So I don't know how compelling it is, but somewhere in here there is perhaps a line of best fit that would go through that data somehow. So to come up with that line, I'm going to go ahead and press stat, go to calculate, and I will select option number 4, which is linear regression. And when I do this, I'll press enter, you can see that I get the equation of the line of best fit. In fact, that equation is, I'll write it down, it's y equals 1.71 times x plus the value of b is 2.35. Now, the next question here, it says, what does the model, that is your least square regression line, predict for when x is 10? So if you look over here, x being 10 is not a value on my data set, right? When x is 10, I don't see a y value at all. So I'm going to use my model to predict perhaps what x would be based on this linear model. And to do that, I'm just going to feed x into this equation, right? So the y value will equal 1.71 times this value of x, which is 10, plus 2.34. So if I type 1.71, multiply that by 10, and then add 2 plus 2.35, I get a value of 19.45. So I'm predicting that when x is 10, right, the prediction is that y would be about 19.45. And then the final thing that it says is find the residual for one of the points that's in the data set. So if you take a look at this data set, 614 is a point in it. And I want to find the difference between what the data set says, the observed value, and what the model would predict for x equaling 6. So the residual is always that difference, right? It's the difference between the observed value, observed, S-E-R-V, the observed y value, minus the calculated or predicted y value. So the observed y in this case is the number 14, right? So part of this is going to be 14 minus something. That something is going to be the value that our model predicts y will be when we plug in an x value of 6. So you can see this is the same model right up here, right? So y equals 1.71 times the number 6 plus 2.34. And if I calculate that, I get exactly 12.61. So this y is 12.61. So you can see here the observed y is 14 and the predicted y is 12.61. So if I take the 14 and subtract 12.61, right, we get a residual of 1 1.39. So it's a positive residual for this point. That means that it should be above the least square regression line. By the way, I've already graphed this. The graph is from GeoGebra is right here, and that point that we were just discussing is this point right here. This was x was 6. The observed value right here is where x is 14. Right, so 14 is what x was right there. And the calculated value, this point on this curve, right, when I plugged in x was 6, it gave me the 12.61. So that residual is just the difference between these 2 points, right? It's the length of that line from the predicted value. Well, it's the observed value minus the predicted value. So the 14 minus 12.61. All right, so that's something that we are probably going to see both on the final, and definitely we'll see this on our individual test tomorrow. So think about that. I hope maybe you have a chance to review this a couple times, watch it tomorrow when you're lining up, getting ready to take the test. This is Mr. Roberts. Have a good evening.